Hello everyone, welcome to Astronautics for Exploit. I am Dr. Ayenshola Ogundele and I will be presenting Spaceplane. The overview of my presentation is as follows: Spaceplane Vehicles, Spaceplane Challenges, Orbital Spaceplane, and Suborbital Spaceplane. Human beings are curious species, always wanting to know what is over the next hill, around the next corner, and on the next island. We have been that way for thousands of years. As a result of the curiosity to explore space, human beings have invented spaceplanes. A spaceplane is a vehicle that can fly and glide like an aircraft in Earth's atmosphere and maneuver like a spacecraft in outer space. To achieve its missions, spaceplane incorporates features of both aircraft and spacecraft. Cargo-carrying spaceplanes have been routinely launched to International Space Station, located at low Earth orbit, for resupply and crew transfers. The guiding principles for spaceplanes are frequent flying, safe travel, ability to land on most runways, and economical operation. All spaceplanes to date have been rocket-powered, but landed as unpowered gliders. There are two main types of spaceplane, which are orbital spaceplane and suborbital spaceplane. Difference between orbital and suborbital spaceplanes are that orbital spaceplanes tend to be more similar to conventional spacecraft, while suborbital spaceplanes tend to be more similar to fixed-wing aircraft. World's first spaceplanes The world's first 5 spaceplanes flew within the first 50 years of human spaceflight are X-15, Space Shuttle, Buran, Spaceship One, and X-37. North American X-15 reached space in 1962-1963 at about Kármán line classifications. Both the North American X-15 and Spaceship One were suborbital. Both X-15 and Spaceship One ascend horizontally from a mothership. Space Shuttle and Buran reached space in 1980s. Both Buran and X-37 spaceflights conducted uncrewed spaceflights. Spaceship One in 2004, piloted by world's first commercial astronaut. The X-37 is the smallest and lightest orbital spaceplane yet flown. Boeing X-37 flew in 2010, and X-37 launches atop Sentinel and Atlas V rockets. This picture shows world's first space planes. The North American X-15 with horizontal ascent, Space Shuttle, Buran, Spaceship One with horizontal ascent, and Boeing X-37 atop Atlas V and Centauri. Spaceplane Challenges. Spaceplanes must be able to operate in space just like the traditional spacecraft, but also must be capable of atmospheric flight like an aircraft. How these requirements drive up the complexity, risk, dry mass, and cost of spaceplane designs. This picture shows space environment into which spaceplanes have to endure in order to be able to achieve its mission. The various spaceplane challenges are launch to space, space environment, atmospheric re-entry, aerodynamic flight and horizontal landing, and propulsion. This picture shows launches of Pegasus carrying 3 space technology 5 satellites in the skies of California. Launch to space. The flight trajectory required to reach orbit results in significant aerodynamic loads, vibrations, and accelerations, all of which have to be withstood by the vehicle structure. Escape system. If the launch vehicle suffers a catastrophic malfunction, a conventional capsule spacecraft is propelled to safety by launch escape system. The space shuttle was far too big and heavy for this approach to be viable, and this results in a number of abort modes that may or may not have been survivable. The Challenger disaster demonstrated that the space shuttle lacked survivability on ascent. This picture shows space shuttle launch. Space environment. Once on orbit, a spaceplane must be supplied with power by solar panels and batteries or fuel cells, maneuvered in space, kept in thermal equilibrium, oriented and communicated with. Thermal and radiological environments. On-orbit thermal and radiological environments impose additional stresses. This is in addition to accomplishing the task the spaceplane was launched to complete, such as satellite deployment or science experiments. This picture shows effects of space environment on satellites and spaceplane. Orbital maneuvering. The space shuttle used dedicated engines to accomplish orbital maneuvers. These engines used toxic hypergolic propellants that required special handling precautions. Various gases, including helium for pressurization and nitrogen for life support, were stored under high pressure in composite overwrapped pressure vessels. This picture shows effects of space environment. Another challenge is atmospheric reentry. Orbital spacecraft re-entering the Earth's atmosphere must shed significant velocity, and this results in extreme heating. Example: the Space Shuttle thermal protection system protects the orbital's interior structure from surface temperatures that reach as high as 1,650 degrees Celsius, that is 3,000 degrees Fahrenheit, well above the melting point of steel. This picture shows Apollo command module flying with the blunt end of the heat shield at a non-zero angle of attack in order to establish a lifting entry and control the landing site. Suborbital spaceplanes trajectories. Because suborbital spaceplanes are designed for trajectories that do not reach orbital speed, they do not need the kinds of thermal protection orbital spacecraft required during the hypersonic phase of atmospheric reentry. The Space Shuttle Columbia disaster was the direct result of a thermal protection system failure. This picture shows reentry of Space Shuttle Columbia. Another challenge is aerodynamic flight and horizontal landing. Spaceplanes must be able to operate in space, just like the traditional spacecraft, but also must be capable of atmospheric flight, like an aircraft. All these requirements drive up the complexity, risk, dry mass, and cost of plane designs. Aerodynamic control services must be actuated. Landing gear must be included at the cost of additional mass. This picture shows aircraft aerodynamics. Another effect, the challenge, is propulsion. All spaceplanes to date have used rocket engines with chemical fuels. As the orbital insertion burn has to be done in space, orbital spaceplanes require rocket engines for at least the portion of the flight. This picture shows SpaceX Dragon. Air-breathing engines. Difference between rocket-based and air-breathing aerospace plane launch systems are as follows. Aerospace plane designs typically include minimal oxidizer storage for propulsion, while air-breathing aerospace plane designs include engine inlets so that they can use atmospheric oxygen for combustion. This picture shows air-breathing aerospace plane. The types of air-breathing engines proposed for spaceplanes include scramjet, liquid air cycle engines, pre-cooled jet engines, pulse detonation engine, and ramjets. This picture shows Skylum plane designed to use oxygen from the atmosphere to burn fuel for at least part of the way to space. Air-breathing orbital spacecraft concept. An air-breathing orbital spaceplane must be able to fly what is known as a depressed trajectory, which places the vehicle in the high-altitude hypersonic flight regime of the atmosphere for an extended period of time. This environment induces high dynamic pressure, high temperature, and high heat flow loads, particularly upon the leading edge surfaces of the spaceplane, requiring exterior surfaces to be constructed from advanced materials and all use active cooling. This picture shows Suborbital hypersonic spaceplane. Orbital spaceplanes. Orbital spaceplanes are more similar to conventional spacecraft. The purpose of orbital spaceplanes are: the orbital spaceplane is designed to support space travel, especially space station, for crew rescue, crew transport, and contingency cargo, such as supplies, food, and other needed equipment. The spaceplane, which may include multiple vehicles, enabled a larger permanent crew to occupy the orbiting research facility, increasing science and research capabilities in space. This picture shows orbital spaceplane rides on Delta rocket. Flown spaceplanes. Presently, 3 types of orbital spaceplanes have been successfully launched into orbit, re-entered Earth's atmosphere, and landed on the Earth's surface. Manned and unmanned spaceplanes are: the manned spaceplane. We have the Space Shuttle, which is manned, Chang'e and Tiantil, which is CSS-HQ. We have the unmanned spaceplanes as Buran and X-37. The pictures here show Space Shuttle, Buran, X-37, and CSS-HQ. Flown spaceplanes. All 3 of the orbital spaceplanes successfully flown to date utilize vertical takeoff, horizontal landing design. This picture shows Space Shuttle launch. The Space Shuttle or Space Transportation System was a partially reusable rocket-launched low-Earth orbital spacecraft system operated from 1981 to 2011 by the U.S. National Aeronautics and Space Administration as part of the Space Shuttle program. This was designed to go into orbit around Earth to transport people and cargo to and from orbiting spacecraft and to glide to a runway landing on its return to Earth's surface. This picture shows Space Shuttle. The Space Shuttle components are orbital vehicle with 3 cluster Rocketdyne RH-25 main engines, a pair of recoverable solid rocket boosters, and the expendable external tank containing liquid hydrogen and liquid oxygen. The Space Shuttle was launched vertically like a conventional rocket, with the two recoverable solid rocket boosters operating in parallel with the orbital's 3 main engines, which were fueled from the external tank. This picture shows 7th launch of the Space Shuttle and 2nd liftoff of Challenger on June 18, 1983. Buran, which is also known as Buran-class orbitals, was the first spaceplane to be produced as part of the Soviet-Russian Buran program. Buran completed 1 unmanned space flight in 1988 and was destroyed in 2002 when the hangar it was stored in collapsed. This picture shows Soviet AN-225 rear aircraft with the Space Shuttle Buran on its back. First flight of 15 November 1988. The Buran-class orbitals used the expendable Energia rocket, a class of super heavy lift launch vehicle. This picture shows Buran during launch of flight 1K1 on 15 November 1988. The X-37, the Boeing X-37, which is also known as the Orbital Test Vehicle, is a reusable robotic spacecraft. As a spaceplane, it is boosted into space by a launch vehicle, then re-enters Earth's atmosphere and lands as a spaceplane. The X-37B Orbital Test Vehicle in the encapsulation cell at the Astrotech facility on April 13, 2010 in Florida is shown in this picture. X-37. The X-37 is operated by the United States Space Force and was previously operated by Air Force Space Command until 2019 for orbital space flight missions intended to demonstrate reusable space technologies. The X-37B is the U.S. newest and most advanced unmanned re-entry spacecraft. This picture shows X-37B Orbital Test Vehicle. CSSHQ Changfeng Shenyang Xian and Tianqi is the first Chinese reusable spacecraft, and it was launched on 4th September 2020 at 7:30 UTC on a Long March 2F from the Sichuan Satellite Launch Center in the Gobi Desert of northwestern China. After a period of in-orbit operation, the spacecraft was designed to return to the scheduled landing site in China, and it was tested for reusable technologies during its flight, providing technological support for the peaceful use of space. This picture shows Chinese reusable experimental satellite. Suborbital spaceplane. Suborbital spaceplane requires far less energy for propulsion and can use the vehicle's wings to provide lift for the ascent to space in addition to the rocket. The different types of suborbital rocket-powered spaceplanes are North American S-15, Spaceship 1, Spaceship 2, and Spaceship 3. None of the spaceplanes was capable of entering orbit. The spaceplanes began their independent flight only after being lifted to high altitude by a carrier aircraft. North American S-15 was a hypersonic rocket-powered aircraft operated by the U.S. Air Force and NASA as part of the S-plane series of experimental aircraft. The S-15 set speed and altitude records in the 1960s, reaching the edge of outer space and returning with valuable data used in aircraft and spacecraft design. This picture shows black rocket aircraft with stubby wings and short vertical stabilizers above and below tail unit. The S-15's highest speed was 4,520 miles per hour, and this was achieved in October 1967 when William Knight flew at Mach 6.70 at an altitude of 102,100 feet. This set the official world record for the highest speed ever recorded by a crude-powered aircraft, which remains unbroken. This picture shows X-15 being carried by its MB-52B mothership with T-38A chase plane. Spaceship 1. Spaceship 1 was a spaceplane designed and fabricated by Skate Composites, a company owned by aerospace designer Brott Rutten. The ship's development was backed by the Microsoft co-founder Paul Allen in a joint venture named Tier 1. Spaceship 1 was 28 feet long. The seagull-shaped fuselage was about 5 feet in diameter and could carry a pilot and up to 2 passengers. The plane had short, wide wings with a 16-foot span. This picture shows Spaceship One, rocket-powered spacecraft with twin swept wing tail booms, which was designed for suborbital flight. Hybrid propulsion system, pivoting wings further for stable re-entry, white body with blue stars on nose and underside, round windows across nose, 3-seater cabin. These are the components of Spaceship One. The objective of Spaceship One is to develop technology for low-cost routine access to space. Large vertical tail booms were mounted on the end of each wing of the Spaceship One. During re-entry, the rear half of the wings folded upward, increasing drag while maintaining stability. Then, the wings were moved back into gliding position for landing. This picture shows Spaceship One discharged from the White Knight. Launched to orbit back to Earth. The spacecraft was launched in mid-air at an altitude of about 50,000 feet from the underside of its mother ship, known as White Knight, a turbofan-powered airplane. After Spaceship One glided for a few seconds, hybrid rocket motors on it fired for 80 seconds to loft the craft just beyond the atmosphere. Spaceship One axed through space for about 3 minutes and then glided back to Earth without making a complete orbit around the planet, otherwise known as a suborbital flight. This picture shows White Knight with Spaceship One. The design. Spaceship One design carried 3 humans, one of them a pilot, in a sea-level pressurized cabin. Propelled by rocket from an altitude of 15 kilometers in excess of 100 kilometers. Re-enter atmosphere and shared kinetic energy in an aerodynamically stable configuration. Glide transonically and subsonically, and land horizontally on the standard runway. This picture shows Spaceship One flight of September 2004. Spaceship Two, here launched suborbital spaceplane. The scaled composite model 339 Spaceship Two is an air-launched suborbital spaceplane type designed for space tourism, and it was manufactured by the Spaceship Company, a California-based company owned by Virgin Galactic. This picture shows Virgin Galactic Spaceship Two. Carriage of Spaceship Two by White Knight 2. Spaceship Two is carried to its launch altitude by a scaled composite White Knight 2 before being released to fly on into the upper atmosphere, powered by its rocket engine. It then glides back to Earth and performs a conventional runway landing. This picture shows Virgin Galactic Spaceship Two as it took off for its first supersonic flight. Spaceship Two unveiling. This spaceship was officially unveiled to the public on 7 December 2009 at the Mojave Air and Spaceport in California. On 29 April 2013, after nearly 3 years of unpowered testing, the first one constructed successfully performed its first powered test flight. This picture shows scaled composite Spaceship Two spaceplane resting under its mothership, which is referred to as White Knight 2. Virgin Galactic plans to operate a fleet of 5 Spaceship Two spaceplanes in a private passenger carrying service and has been taking bookings for some time, with a suborbital flight carrying an updated ticket price of about $250,000. The spaceplane could also be used to carry scientific payloads for NASA and other organizations. This picture shows Spaceship Two in a captive flight configuration underneath White Knight 2, during the runway dedication of Spaceport America in October of 2010. Spaceship Two VSS Enterprise. On 31st October 2014, during a test flight, the first Spaceship Two VSS Enterprise broke up in flight and crashed in the Mojave Desert. A preliminary investigation suggested that the craft descent device deployed too early. This picture shows Spaceship Two performing first glide flight. Spaceship Two VSS Unity. The second Spaceship Two spacecraft, known as VSS Unity, was unveiled on 19 February 2016. And the first flight of VSS Unity, about 50 miles altitude, took place on 13 December 2018. Spaceship Two is designed to carry 2 pilots and 6 passengers on suborbital flights. This picture shows Spaceship Two. Spaceship Three, VXS Imagine. Spaceship Three is the same as Spaceship Two. It is designed in a modular fashion to enable a quicker turnaround time for reflights. Spaceship 3 has a quicker reform edge over Spaceship 2 due to Virgin Galactic's shift in focus to production-intensive operations. Spaceship 3 picture is shown in this slide. For more information, contact Astronautics for Exploit. Thank you.